Hey there, today we'll be doing this question that's 916 words subset. And the question is you are given two strings, arrays, words 1 and words 2. A string B is a subset of string A if every letter in B occurs in A, including multiplicity. For example, WRR is a subset of warrior but is not a subset of world. Why? Because the multiplicity means the occurrences also. So W is present there in both of these, but RR is just present here and not in the world. A string A from words 1 is universal if for every string B in words 2, B is a subset of A, and we just need to return an array of all universal strings in the words 1, and we can return them in any order. So, what does the question tell us to do? Let's understand that properly. So, taking this example 1, what we have is words 2. Let's just take this. We have E and O. Okay. So, first we'll be taking on the first word, that is Amazon. In, in Amazon, do we have E and O both present there? Obviously not. So, we move on. In Apple, do we have it? Okay, we see that E is present there, but O is not present there. So, we move on. Coming to Facebook, we see that E is present there and O is also present there. And mind you, the number of times O is occurring in Facebook is also mattering here. Since O is needed only one time, we can just go on because O is here two times, but we just need to have one O. So we can just move ahead, okay, by taking this Facebook as our answer. So Facebook is added to our answer. Now coming on to Google, we see that O is also there, E is also there, so add it into our answer. Coming on to Leetcode, E is present there and O is also present there. So we just add it to our answer. And let's understand this with example 2 and it will be clear. Coming on to the words 2, we see L and E need to be added. So Amazon is there. So do we have L and E? Obviously not. So move ahead. In Apple, do we have LNE? Yes, we have it. So add it to our answer and move ahead. In Facebook, do we have LNE? Obviously not. So move ahead. In Google, do we have? Yes. Add it to our answer and move ahead. And similarly, in Leetcode also LE is there. So just add it and move ahead. Now let's just change this input parameter, not just from E. Let's just say we need to have EE. So this will also take care of the cases where we have more occurrences present there. So now what we need to check? We need to check in my words if we have L and also EE present there. Mind you, the occurrences are also important right here. So in Amazon, do we have L and EE? No. Move ahead. Apple, only L is present there and only one occurrence of E is present there. But we need two E, right? So we cannot take it. So just move. Facebook, no chance, move ahead. Google, yes, let's just see. L and E, again, we need two E's, so move ahead. But in lead code, if you see, we have L and two E's, so we can actually take this, right? So this will be our answer if this were to be our input in words 2. Fine. So I hope you have understood the question. Now let's get on to the algorithm part and the intuition as well on how to do it. So the approach to this problem would be something like, first of all, you just need to take care of this words to array. And why so? If you just at least just compute what you need. So basically, at first, you just need to have some frequency of the characters which you need. That means here you need how many? You need one L and one E. So if you just know that, okay, these are the things that I know, then you can obviously iterate on this part and check, does every string have these things that you need, right? And if that string satisfies this condition of having this thing, that is this words array part, then you can just add it to your answer. Okay, so this is the basic intuition. Now let's get on to the implementation part on how you will be implementing it. That is the main part, right? So what we can at first do is we can let's just again change the input. That will be a better one. So LEEE is a better example here on this. So I'll be taking the words 2 as L, E and E. Fine. So at first, what you can say is that you'll create a frequency array, fine, of size 26. That is A to Z. I'm not writing the whole part. Okay. So here will be A, B, C, D, so on up till L. L will be there, and somewhere E will be there. Okay. I'm just writing these two because here we are only needing L and E, and the space is not much, so that is why I have not written the whole thing. But there are A, B, C, D, E, many things are there. Okay, as in the characters of alphabet. But now we see that we have a frequency of L and E. How we will get it? We'll just iterate on the words too, right? And we'll increment all the values by 1 if it is here in words too. So L, what is the frequency of L? 1. Now get on to the next string. In this string, what are the characters? Just increment those frequencies. So E is a character. Again, E is a character. Mind you, this is E, not C. So two E's are there. So we'll increment the value of E by 2. Now the frequency part is done, right? So now we know in every string we need at least this thing right here. That means when we iterate on words one or Apple or in Facebook, Google, Leetcode, we will need these things. That is two E's and one L. At least we will need that. We can have more than three E's also here. Like in Leetcode, we have three E's, but we only need two, right? So this is the condition that you need to implement. That you just need to go through the words array, that is words one, and check for if this condition is fulfilled by every string that is present here. So now let's get on to the implementation part. Now once you see the code, everything will be clear. So I'll just erase this off. Coming on to the first part, what we have done here is just declare a frequency array of size 26 like I told you. Iterate on the words too, that is this one, which is given here, that is E and O. Okay, and just make sure that all the frequency have been updated. And why did I take max? This might be a question coming to your mind. Let's see, why did I take the maximum frequency? Now coming here, we see that I'll just change the input again, that is to LEE, and remove this part. So in words too, if we have LE and E, so what we know is we need at least this much, we need at least two E's right here. So what we can do here is, if we have something here as EL also, let's just say the input, I'll write it better. I'll just erase this and write it in a clear manner. Let's just say the input is EL and EE in words too. Okay, so mind you, this is words too. So if we have EL and EE, so what did we do? We incremented all the frequencies, right? So somewhere here we have E and somewhere we have L, okay, in our frequency array. So what we did was we incremented the frequency by maximum. Why so? Because if you see here, you are needing one E. Fine, that is perfectly fine. Here you are needing two E's. But if you increment the value of E by 2 right here, let's just say, okay, since we are needing 2, it is also taking care of the part wherein you need 1 E, right? Just think on it, you'll understand it. See, like something like here, let's just say this thing, that is E and L, right? E and L. So you need E and L in every words of one string. El has to be present everywhere here, right? So you need one E for that, but you also need to take care of the fact that EE should be present there, right? In every string of words one, EE should also be present there. But since I had taken the maximum value or the maximum frequency of E, that is 2, it is also taking care of the fact that I also need one E. Okay, so just think on it a little and you'll understand it, why I took 2, okay, or the maximum frequency. Just write it down somewhere, you'll understand it. Otherwise just replay that part, you'll understand it perfectly, because this is the main part, that is you have to take the maximum. Okay, so if you just take on the maximum part, it is also covering the part wherein you are needing less than values something like that. Fine. After the frequency array has been updated, it is very simple. You just iterate on the words array. You create another frequency array saying that, coming right on to here, saying that what are we doing in the frequency array of this part right here? We are incrementing whatever's present here. That means in Amazon, what we will do, we'll just see what are the words, or sorry, what are the characters that are present here. So in the frequency one, I'll just write it here also, AMAZON. So these are the characters that those frequencies will be incremented. So A's frequency is 2, M is 1, Z is 1, O is 1, and N is 1. Okay. And in words 2, what are the frequencies that were updated? Taking this input only, that is EO is marked as 1 and 1 according to the frequencies. Now, what are we doing on the next part? That is, we'll be checking that in the frequency array, that is right here, whatever the frequency is, that is we need E one time and O one time, right? So mind you, in this frequency array, A, B, C, D, many other things are there also, right? But their frequency right now is 0. So if we need something that is E, we are needing E. But in my frequency array of this string, that is Amazon, when I create it again, do we have E here? Obviously not. The frequency of E is 0, but I need one of them, right? So we can just directly break out of this loop. Why? Because we do not have an E present there. Fine. So this is where the checking part is done. So I'll also write this down if you are getting confused. That is, this is just calculating calculating the frequency of words one string. Each word, okay, each word's one string. So this is the part where this is done. After that, I'm checking that I need at least frequency of I characters at least to make this to be true. But if that does not happen, we can just simply break out. But if we can, we push it back into our answer and we just return the answer vector. So I'll just explain this part again if I might confuse you, okay? Because it looks like it is confusing you, but I'll just do it anyhow. So what this part is doing, this part is just adding up the frequencies of the words one part. Fine. So this is the part where it is done. I'll just take another example right here, so it is absolutely clear to you. Fine. And there is a frequency array which is present here. Fine. And there is another frequency of one array which we are taking, and this is our string present here. So this dry run should make everything clear to you. So the frequency array says, and I'm taking the first input as E and O is marked in my frequency array as 1. In my frequency array, what do we have? We have the characters O whose frequency is 1, and the character E whose frequency is again 1. Now in my frequency array, what we are doing, we are making sure the Amazon, whatever the frequency of these guys are marked here. So A has occurred how many times? 2 times. M has occurred one time, Z has occurred one time again, O has occurred one time, and N has occurred one time. Now let's just delete this part. Now we just need to check that what we are doing here is we are just checking the frequency from 0 to 26. We are checking for every character, that is A to Z. We are seeing, okay, in my frequency array, what is the value for A? If nothing is there, obviously it means 0 is there, right? But we need a obviously not, so we do not care about that. We just care about the part that is O and E. So in my frequency of 1, does it satisfy? Yes, 1 and 1 satisfied, because this is also 1 here and this is also 1 here. But does E satisfy? See, in my frequency of 1, there is no occurrence of 1, right? That means the value is 0. So frequency of 1 of E is right now 0 obviously, and frequency of E is 1. But this should not happen, which is the case which I have written here. That means if such condition happens, that is in my what I need, that is E, is not present in my frequency of 1, we just break out and we just return. Fine. So this is the whole part of the implementation one. And yeah, if you did understand this question also and like the explanation, please do like and subscribe. And yeah, I've already submitted this code by the way, so you don't need to worry about that. And if you need the code, just comment down, I'll paste it down there. And the time complexity saying would be here 26 into n into 10. So basically the time complexity turns out to be, if you just remove the constant parts, that is n plus m, okay, wherein n is the total length and m is the words